Hello and welcome to another video. In this video, we're going to be working on maximum score after splitting a string. And in the problem, you're given a string of zeros and ones, and you want to return the maximum score by splitting the string into two non-empty substrings, left and right. The score of the string is the number of zeros on the left side and the number of ones on the right side. So in this first example, they show you the best way to split is right here. And if you split like this, you would get 4 here and 1 here, and that gives you the maximum total. And in the second example, the best way to split would obviously be right here, right? So you'd have 2 zeros on the left and 3 ones on the right. In the last example, you have to split. You can't have the whole string. So ideally, you want to have as many ones as possible on the right. So you would just split like this. So this would be 0 and this would be 3. So the idea here is let's just draw an array to represent this string. So let's just say we have something like this, and then we'll just have zeros and ones. So we'll have like 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, something like this. So obviously you can kind of brute force it, right? You can just take every single start index, like let's say you pick here, and you would just go through every single one, right? So you could go to here, to here, to here, to here, and so on. And you would just manually calculate whatever subarray you pick, or actually, it wouldn't be like that. It would be, you pick every single split index, right? So you pick like here, calculate how many zeros are here, how many ones are here. Then you'd move over here, calculate, and so on, right? And essentially, this would give you an n-squared solution because you would split at every single location, so that would be n-squared. So there's another way you could do it that's going to be better, and you can kind of get intuition for it, and then you can even optimize it. So another thing we could do is we can make another array, and we can just simply have the count of zeros and ones available. So let's just say we only store the count of zeros. So we would say, like, we know we have to have a split. So what we're going to say is for an index, that index will represent splitting at that index. So if we pick this index, for example, that means we're going to be splitting right after it. If we pick this index, we're going to be splitting right after it, right? So the index will represent the last item of the left subarray that we will split into. And we can just count up the zeros as we go, right? So we can say, like, okay, let's just count this way. And let's write down these totals. So this will be 1, 0. This will be 1. And it's going to be a cumulative count, right? So it's going to be a cumulative count from the start to the place where we're splitting. So if we split here, for example, we'll have 1, 0, right? So it's going to be 1, 1, 2, 3, 3, 3, 3, like a prefix sum for, 4, 4. And now, let's say we want to split here. We know by just like going through the index how many zeros are on the left. And similarly, we can do the exact same thing. We can have another array for the right, so we can just have one more of these, right? That we can just pre-compute by doing a one pass. So essentially, we can do the same thing. We could say, like, okay, well, we can do the exact same thing for the right. We could say, like, if we split here, let's say, that means the number of ones will be the ones right after this number. So this will be so here, you can't really split. You can't split like this, and you can't split like this. But yeah, essentially, if we're saying if we do split here, this will be the number of ones right after this number. So this will be like 0 ones, 1 1, 2 ones. It'll be 1 1 behind, basically. 1 1, 2 ones, 2, 3, 4, 5. 5. 5 again, and 6, I believe that's correct. So essentially, if we split right here, let's say, that means that we're going to have 6 ones on the right side, right? Which is correct. We have 1, 2, 3, 4, 5, 6. And it's lagging one because the index we split at will be the leftmost index of the left side, right? So let's say we split here. That means we're splitting like this. That means we have no ones on the right. Same thing here. If we split like this, we'll have 1, 1 on the right, and so on. A little bit confusing. So turns out we don't actually need these arrays. Like, we don't need these cumulative counts. What we can do instead to optimize this is we can just pre-compute the count of ones or zeros, whichever one you want. I'm going to pre-compute the count of ones beforehand. So we're just going to pre-compute the count of ones. So we'll just go through it. We'll say, like, okay, well, we have 6 ones, right? And now we can just, as we go, we can just keep track of how many zeros we have, and what the split will be. So let's kind of walk through how this will go. So we pre-compute the ones, and we can literally just go left to right now. Instead of using these two arrays, we can just do this on the fly. So we're going to have a result, and it'll just be 0 for now. So essentially, like here, we'll say, okay, if it's a 0, and this will be the number of ones, so we can write this down. So this will be the number of ones, 6, and get rid of this, and zeros will be 0 for now. Okay, so we're going to go through our numbers. We're going to say, okay, is it a 0 or 1? If it's a 0, then we will add 1 to the 0. So we have 1, 0, and then we still have 6 ones, right, because it's a 0. And remember, the index we're at means we're splitting like this, right? So this index means we're splitting like this. So what will be the total here? Well, we have 1, 0, and we've pre-computed our 1, so we know we have 6 ones to the right. So the total here will be 7. Then we can move on, right? So we can say, let's actually use an actual arrow so this doesn't happen. There we go. So now we move over here, and we'll say, is it a 1 or a 0? It's a 1. And remember, we're splitting like this. So if it's a 1, there will be 1 less 1 on the right side, right? Because we just reached one of them. So we're going to subtract 1 from the ones now. So we'll have 5 ones, and now our total will be 6. So let's double check this. We have 5 ones on the right and 1 0, so that is correct. So we have 6 here. Then we move it again. Is it a 1 or a 0? It's a 0, so we will add 1 to the zeros, because remember, we're splitting right after the number like this. So now our total will be 7, which is correct, right? We have 2 zeros and 5 ones. And you basically keep doing this, so we can do this pretty quickly. And let's just kind of, let's just do this pretty quickly. So we have another 0, which means now we have 3. And this should be our biggest total so far, because we have 3 zeros here and 5 ones here. So this is 8. Move it again. We have a 1, so we'll subtract 1 from the ones because we have 1 less 1 on the right. So we have 4. You know this is going to be worse. We go over here. We have 3. Go over here. We have 2. Go over here. There are 4 zeros now. Once again, just to double check quickly, there are 4 zeros and 2 ones. Go over here. There's 1 1. And then at the end, there will be, we go over here. So you can't actually do a split like this, by the way. So we will just loop the second time up until this part, right? You have to split where at least there's one number in the second one. So we will just loop from the start up until the second to last index, meaning our last split will be like this. We can't split like this, right? We can't have an empty array. And that's pretty much it. So you can just pre-compute the ones and keep track of the zeros on the fly. Similarly, if you want to, you can go backwards, pre-compute the zeros and keep track of the ones on the fly, and just start here with your splits. So you remember, you can't split here, so you would start like here with your splits, and you'd keep track of the ones. Like I said, the ones are a little bit trickier because the way I have it, the arrow will mean that that's the last number in the left side. It's going to work a little bit easier if you do the lefts, because if you do the ones on the fly now here, so it's going to be the ones on the right. So you're just going to want to have like the value before the one you're on, which is like I showed you with those 2 arrays. They're a little bit off and it's a little weird. But you can also do it the other way. You could say like this is the first number on the right array. You could totally say that, right? So you could say like instead of this being the last number on the left array, this will be the first number on the right array. So our split will actually be over here. And that would also basically be the same as the zeros. So either one works. And that's pretty much it. So now we can code it up. So we're going to count up our ones first. So we'll just say like ones equals 0, and then we'll just count them up. So we'll say like for car in S, if car equals 1, ones plus equals 1. So there we go. Now we'll have our zeros. We'll have the count equals 0. And now we're going to loop from 0 up until the second to last index, because remember, the way I have it, the character we're at will be the last character in the left side, and so we can't have it over here. So we'll just say for I in range length s minus 1, we'll have a result variable. And essentially now we're going to do our logic, right? So if si equals 0, we will add to the zeros. Otherwise, it's a 1, so we have to subtract from the ones. And we will just maximize our result here, as always, so maximum result and zeros plus ones. And finally, return. And that should be it. So the time for this one is oven, and the space is O1. And yeah, so another easy problem, and I guess it's because the holidays are coming up, so hopefully you enjoyed that one. If you did, please like the video and subscribe to the channel.